and so forth. Let's move to the weighted goal programming. The important issue here is to decide the related weights. The decision will be made by the decision-making team, the managerial board, based on the situation. Pay attention that weights can be revised and we can get a proper set of weights by solving the problem and readjusting them based on the solution we obtain. And one of the proper ways to assign weights for the deviation is based on the certain amount of deviations, as we might be dealing with different types of units, and in order to include all of such deviations in a single objective, they need to be standardized. Assume that the weights are, well, 1% deviation from a current goal. And the following table shows the related information that the managerial team has decided. For example, they say that, okay, I have for the variable C+, I have the goal of 1800. What is the 1% of this deviation? It is 18. And they have decided that the related weight for this should be equal to 80. And the same for the rest of the variables. And when you see that minus there, minus 50 weight for the C minus variable, well, it is not a surprise that managerial team has decided to give that a minus weight, and because of the minimization nature of the problem, where our priority is to have a downward deviation. And now I can obtain the related standardized weights for W1, which is the weight for the C+. The only thing that I need to do is to divide the 80 over 18, which is the associated weight by the decision-making team for 1% deviation of the first variable. And doing the similar process for the rest of the variables, I have the related weights generated, and now I can proceed with the approach. As you can see, the objective function will be, well, consist of only the deviation variables, while the original cost objective will move to the constraints section with its related new deviation variables. And by solving this problem using Lingo, I get these values, as you can see. C plus equal to 0, C minus equal to around 1133, and I have a 0 value for D minus 1 and D minus 2. D minus 3 gets the value of 55.33, x1 as 3.33, x2 0, and the objective function equal to 2484. Now let's replace the values in all of the constraints. For the first goal, well, it is exactly 1800, so I've done a good job here. For the next goal, regarding the product number 1, I have 40, which is good. The next one, 20, again, it's good. How about the last one? Well, if I replace these, what I get is 2667. So here, the goal was not satisfied. And that's the reason I'm having the D3 minus equal to 55.33. So in summary, what I did was to generate some weights according to managerial team's opinions, the decision-making team's opinions, and implement them in my model. And this model will try to minimize the deviations of my goals as much as possible. If I get the value of 0 for those deviations, I have done a really great job. But if there is some value for those deviation, I have a deviation, it means that I am deviating from my goals to a certain amount. Now let's go to the primitive goal programming approach. All the steps for developing the model will remain the same except for the objective function, and we are not dealing with the weights anymore. Here we should decide the priority levels for the goals. I mean, we should specify the first important goal, then the second most important goal, and so forth. Let's assume that the decision-making team again has provided us with the following priority sequence. So priority number 1 is minimizing the extra amount of the product number 2. And the reason for that is because it is of hazardous type, and storing this product has a high risk to the staff. So, okay, let's first deal with product number 2, because it's dangerous. We can't hold it. We can't hold the extra amounts at the site. The priority number 2 is minimizing the cost, and priority number 3 is minimizing the total extra amount of products, as we have a limited inventory space. So the first model, according to the first priority, will be minimizing of, well, D minus 2 with the set of constraints that I had. What I get from solving this model is having D minus 2 as 0, D minus 1 equal to D minus 3 equal to 0, C plus 540, C minus 0, x1 6, x2 6, and Z star 0, which was obvious because I'm trying to minimize D minus 2, and it will get a value of 0 here. Let's replace in the constraints. Well, the first goal, I'm doing a good job, and I can see from the amounts of the deviations that I have. The next one, I have 132, which is more than what I want. The next one is 48 and 108. Let's move to, after I'm done with this priority, what am I going to do is to fix the value of D minus 2 in the next priorities constraint set. I will treat it as a hard constraint. And the second priority was about minimizing the cost. The related objective function for this priority would be C plus minus C minus, and I have the hard constraint D minus 2 equal to 0. So I will solve this and get the related values here, as you can see. And now, what is my next step? You will get the process of what am I doing in the graphical solution maybe much better, but we are dealing with the mathematical solutions first. I'm using Lingo for these values. So after solving the second priority, I'm moving to the last priority. Again, what am I going to do here is treat the objective function of this and this priority as a hard constraint for the next priority. So as you can see, I have this value, and the value of this is exactly the Z star. So I'm replacing it in the next priority. I'm treating it as a hard constraint. And when I apply this, I will get the related results. So I only need to work 3.33 days per week using production unit number 1. And what will be the result here? You can see that all my goals are satisfied, except for the number 3. So let's move for the graphical solution. Before moving forward, please make sure you read the related question in your textbook. So there is an electrical utility that utilizes 2 types of energy sources, including the hydro and the thermal. The thermal section is based on fossil fuel and nuclear energy. And the model is mainly focused on the thermal-electric station. And you can see the model in this slide where F represents the amount of fossil fuel thermal power, and N represents the amount of nuclear thermal power. Now, what I have here is that the management team has provided us with some priority. Priority number 1 is the power shortage. Number 2 is the profit shortage. Number 3 is excess pollution. 4 is excess in the proportion, and number 5 is the power surplus. We can show these priorities in the objective function, as you can see, as PIs. For example, the first one, P1, D minus 1, shows that my first priority is regarding D minus 1, which is a power shortage, and so forth. Therefore, what I have here is that the first 4 constraints can be treated as goal constraints. Constraint number 1 is of equality type, meaning that both underachievement and overachievement will be included. The second and third include only overachievement, while the last one is of underachievement type. And we have 5 defined deviational variables and 5 priorities, which I mentioned earlier. Now, you might think that I have 7 variables in the model and I will not be able to solve it graphically. However, the good news is that we only have 2 decision variables here, namely F and N. And we would be able to solve the model by creating several subproblems sequentially. And in each of these subproblems, all the elements will remain the same except for the objective function, and the resulted goal, the related goal constraint. Moreover, what I have here is in each of the subproblems, we will only consider one deviational constraint.